Okay, last section with radicals. We are going to multiply binomials with radicals. And to be fair with you, I think this is pretty difficult in a lot of ways. Remember our old friend distribution? Well, if I have 3 on the outside of parentheses for the square root of 7 and 2, I have to distribute it to both. So I would have 3 square root of 7 plus 3 times 2 is 6. And if I had, say, negative 5 times 5 minus the square root of 6, negative 5 times 5 is negative 25. And negative 5 times negative square root of 6 is positive 5 square root of 6. I wish I could tell you it doesn't get any harder than this, but it does. It's a really challenging topic, and kids have always had difficulty with it. Square root of 3 times square root of 3 plus square root of 5. Okay, square root of 3 times square root of 3 is square root of 9, which is 3. Square root of 3 times square root of 5, you simply multiply them together and you get square root of 15. Square root of 7 times square root of 6 plus 2. That's square root of 7 times square root of 6 is square root of 42, which does not have a prime factor, but you can prime factor it and see if you get anything. And square root of 7 times 2 is 2 times the square root of 7. Here's one that's a little bit tricky, but you've seen an example of this already. Is, say, 4 squared to 7 squared. Well, that's, let me change that to a 3 just for arithmetic reasons. Well, 3 squared is 9, and square root of 7 squared is 7, so that's 63. What's different between this one I just showed you and this is that's an example of a binomial squared. And when you see a binomial squared, the first thing that should come into your mind is you're going to have to FOIL it. So what I like to do is I like to rewrite it. Instead of it being squared, just rewrite that binomial twice and then start the squaring process. As far as 5 times 5 is 25. 5 times the square root of 3 is just what it says, 5 times the square root of 3. That's the outside and inside parts. And then square root of 3 times square root of 3 is 3, but you're going to have some combining here. 25 and 3 make 28, and then 5 square root of 3 plus 5 square root of 3 would be 10 square root of 3. So there's a number of different concepts that are all inclusive in the same thing. Let's do one more like that to make sure we got a handle on it. I'm going to throw in the variable x, but it shouldn't make any difference. So we see that it's a binomial squared. We go ahead and write it twice. And then we ask ourselves, okay, x times x is x squared. And what is x times negative square root of 5? Well, it's simply negative x square root of 5. And you've got one, and you've got another one. The outside and the inside parts of the FOIL. And the negative square root of 5 times negative square root of 5 is going to be positive 5. So if you're looking at the center and you're saying negative x squared of 5 and negative x squared of 5 should be negative 2x square root of 5 when you combine them. So like I said, it's a little bit different. I want to do a couple that are sum and difference. These are ones that you would see as the result of FOILing the difference of two squares. So here you'll see 25 minus 5 square root of 3 plus 5 square root of 3. Oh, it's an ugly radical, sorry. Minus square root of 3 times square root of 3 is 3. So that's 25 minus 3 is 22, but then notice whenever you do a sum and difference model like this, the outside and inside parts of the FOIL are going to cancel. That's all you got, 22. Throw in a variable, and you've got x minus square root 11 and x plus square root 11. So again, x squared, and then we're going to have, and then negative square root 11 times positive square root 11 is negative 11. Notice the outside and inside parts of the FOIL will cancel. Bloop. And then I've got 3 more, and they are increasing in difficulty. The first one, 2 square root of 5 times 3 square root of 3 plus 4 square root of 5. Well, 2 square root of 5 times 3 square root of 3 is 6, right? We multiply the 2 times 3, and then inside the radical we have 5 times 3, which is 15. And then we have 2 square root of 5 times 4 square root of 5. So 2 times 4 is 8. And square root of 5 is square root of 25. But notice the square root of 25 is a perfect square because we multiplied square root of 5 times square root of 5. So that, in effect, is just 5. And 8 times 5 is 40. So we got a number of different steps in here. I'll show you this one, and then I'll show you a monster at the end. And if you can handle the monster, you're going to do just fine with all this. Okay, so in this one, it looks like 8 times 3 is 24, square root of 2 times square root of 3 is 6, and 8 times 5 is 40, this is 10. Okay, that one was pretty straightforward. Didn't have to simplify any of the radicals, which is good. And now take a look at this monster. And we're going to do this together, and I'm really hopeful you're going to do okay with it. So I've introduced variables inside of radicals. I've got them to high powers. But let's stick with just the techniques that we know and see what we can do. So we multiply this times the first of the terms in the binomial. 3 times 2 is 6. And then inside the radical we have 10 times 5 is 50. X squared times x squared is x to the 4th. So we're not done with that, but we can put that aside now and focus on this guy times the second term in the binomial. 3 times 3 is 9. And then inside the radical, 5 times 5 is 25. X squared and x to the 4th is x to the 6th. Well, if we look at 50 and we prime factor it, look at there, we got a pair. So that 5 has to come out. Multiplied by the 6 makes 30. I've got x to the 4th, so that means there 2 x's are coming out, representing 2 different pairs. But I still have this guy left over who's got to stay inside the house. And then same thing here. 25 is a perfect square. The square root of 25 is 5. 5 times 9 is 45. And then I've got x to the 6, which means I have 3 pairs of x's. And there you go.